An algorithm is a step-by-step procedure for accomplishing a task. In this example, the algorithm has several steps, including sub-steps that are performed according to a certain condition. Step number 1 is performed, then step 2, step 3. If the condition is true, then the sub-steps are performed. Notice that here, some of these sub-steps may affect the original or the underlying condition, changing it to a false statement. If that's the case, then the algorithm will perform steps 4 and 5. And if the condition is still true, then again those sub-steps will be performed again. This is an important element of an algorithm. It's called a loop. A loop is a set of steps that can be repeated while a certain condition is still true. To illustrate how an algorithm works, consider this sum of numbers from 1 to 1,000. A very simple way of putting this in an algorithm would be to start with a variable and then we add numbers to that variable. Here we start with the variable s being equals to 0. Then the next step of this algorithm would be to add 1 to the variable s. At this point, the value of the variable s would be 1. The third step of this algorithm would be add 2 to the variable s. At this point, the variable s will assume the value of 3, since previously the value was 1. As we can see, we're simply adding each number to the variable s. Eventually, we'll reach 1,000, and that will be the final addition. And then the very last step is to show the value of the variable s. Now, this is not the most effective way of creating an algorithm for the sum of numbers from 1 to 1,000. There are two problems here. One is that this algorithm will be extremely long. It will have at least 1,000 steps. And also, the algorithm works only for this type of sum. If we want to add numbers from 1 to 2,000, for example, then we will need to modify the algorithm and then include or add more steps. Not a very efficient way. Let's take a look at another algorithm that is much more efficient that will allow us to compute that sum. The algorithm works as follows. First, we give the value of 0 to the variable s and the value of 1 to the variable k. Now, the variable k is a variable that will help us keep track of these numbers that you see in this sum. So initially, the variable s has the value of 0. Then we're going to add to s the value of k, which at this point is 1. Then we increase the value of k to 2. Then we add the value of k again to the variable s. Then we increase the value of k to 3, and we add the value of k to s. Notice that the procedure is the same. The steps are the same. We always add the value of k. And k is a variable that is increasing by 1. Then k becomes 5. And then we add 5 to the variable s. This process can be repeated for as many times as we want. Eventually, k will reach the value of 1,000. And that value is added to the variable s. Now, the algorithm will also increase the value of k to 1,001. So we have to decide when to stop. So we impose a condition saying that we will do this addition of the value of the variable k to s as long as k is less than or equal to 1,000. So we keep doing this while k is less than or equal to 1,000. Here's a flowchart of the algorithm. First, we define the variable s to be equals to 0, and then we define the variable k. K is called a counting variable or a dummy variable. And then here's the condition that we check. Is k less than or equal to 1,000? If so, then we're going to add the value of k to the variable s, and we're going to add a value of 1 to the variable k. The algorithm will go back to the condition and check it. Is k less than or equal to 1,000? As long as k is less than 1,000 or equal, the algorithm will perform the 2 sub-steps and check the condition again. Now, the algorithm will only continue to the next step if this condition is not satisfied, which means that k is not less than or equal to 1,000 anymore. At that point, the algorithm will show the value of the variable s.